Finding the length of a vector. Find the length of the vector u, where u has the components -1 and 1/4. So let's take a look at our definition for finding the length of a vector. So we see that to find the length of a vector, we take the square root of the sum of the squares of the components. So to find the length of this vector u, we take the square root of, we take the square of the first component, which is the square of -1, and we add the square of the second component, which is 1/4. And so this is going to give us the square root of 1 plus 1/16, and that will be, when we combine these, the square root of 17 over 16. And so that's going to be, we can rewrite this as the square root of 17 over the square root of 16, and we know that the square root of 16 is 4, so this will become the square root of 17 over 4. So here we see that the length of this vector u is going to be the square root of 17 over 4, using our definition of the length of a vector in Rn. In this case, we're dealing with R2. Find the length of the vector v, where v is a vector in R2 with components 4 and -1/8. So let's look at our definition for the length of a vector. So to find the length of a vector, we simply take the square root of the sum of the squares of the components. So to find the length of this vector v, we take the square root of, we take the square of the first component, 4 squared, and we add the square of the second component, so the square of -1/8. And this will become the square root of 4 squared is 16, and the square of -1/8 is 1/64. And what we'll do is we'll have to get a common denominator. So the 16 will get multiplied by 64 over 64, and we'll add 1/64. And this will become the square root of 1025 over 64, or the square root of 1025 over the square root of 64. Now, of course, the square root of 64 is 8, so this will be the square root of 1025 over 8. And we can note that we can simplify the radical. So for the square root of 1025, we can rewrite it as the square root of 25 times the square root of 41. So we'll get that over 8. And the square root of 25 is 5, so this will give us 5 times the square root of 41 over 8. And so the length of our vector v is going to be 5 times the square root of 41 over 8, and we found this just using our definition for the length of a vector, in this case in R2. Find the length of u plus v, where u is the vector in R2 with components -1 and 1/4, and v is a vector in R2 with components 4 and -1/8. So we have a definition for finding the length of a vector. Our definition says that to find the length of a vector, we simply take the square root of the sum of the squares of the components. But in this case, we're finding the length of the vector u plus v. So we're first going to have to determine u plus v. So we're going to add the vector u with components -1 and 1/4 to the vector v with components 4 and -1/8. And when we add these together, we'll add component to component. -1 plus 4 is going to be 3, and 1/4 plus -1/8, that will be 1/8. And so we're going to find the length of u plus v. So we'll take the square root of the square of 3, so we have 3 squared, plus the square of 1/8. This will give us the square root of 9 plus the 1/64. And getting a common denominator, we get the square root of 9, we'll multiply by 64 over 64, and we'll add 1/64. This will ultimately give us the square root of 577 over 64, which we can rewrite as the square root of 577 over the square root of 64, and the square root of 64 is 8, so this will give us the square root of 577 divided by 8. And so this is going to be the length of the vector u plus v, which we obtained by adding the vectors u and v, and then of course we found the length using our definition for the length of a vector, in this case in R2. Finding dot products. Find the dot product of the quantity 3u minus v and the quantity u minus 3v when u dotted with u is equal to 8, u dotted with v is equal to 7, and v dotted with v is equal to 6. So we should note that the dot product does satisfy the distributive property, which means that we can take this 3u and dot that with the quantity u minus 3v, and then we can take minus v and dot that with the quantity u minus 3v. And so we used the distributive property once, now we'll use it again. So we'll have 3u dotted with u, and then minus 3 times 3 is 9 times u dotted with v, and then we'll have minus v dot u, which we can rewrite as minus u dot v because the dot product is also commutative, and then we'll take minus v and dot that with negative 3v, giving us positive 3v dot v. And we can see that we were told that u dotted with u is equal to 8. So we'll get 3 times 8 minus 9 times u dotted with v, that's given as 7, minus u dotted with v, once again, is 7, plus 3 times v dotted with v, which is 6. And so this will give us 24 minus 63 minus 7 plus 18. And so that will give us 42 minus 70, or negative 28. So in this case, the dot product of the vector 3u minus v and the vector u minus 3v, that's going to be equal to negative 28. And we were able to find this by knowing that the dot product satisfies the distributive property, and it's also commutative.
Finding the angle between two vectors. In the exercise, find the angle theta between the vectors. Vector u is cosine of pi 6 sine of pi 6, and vector v is cosine of 3 pi fourths sine of 3 pi fourths. To find the angle theta, we can use the equation that the cosine of theta is equal to vector u dotted with vector v divided by the magnitude of u times the magnitude of v. Simplifying or plugging in the values of u and v for the numerator, we will have u dotted with v, therefore we will have cosine of pi 6 times cosine of 3 pi fourths. And we will add to that sine of pi 6 times sine of 3 pi fourths. This will be divided by the magnitude of these two vectors, so it will be the square root of cosine squared of pi 6 plus sine squared of pi 6 times the square root of cosine squared of 3 pi fourths plus sine squared of 3 pi fourths. Simplifying the numerator and the denominator. For the numerator, we can use a trigonometric sum difference formula to rewrite this as just the cosine of pi over 6 minus 3 pi over 4. For the denominator, both of the square roots are the cosine squared plus the sine squared of the same angle. Therefore, this will just be the square root of 1 times the square root of 1. Or this will be equal to cosine of negative 7 pi over 12. And this is still equal to cosine theta on the left-hand side. Since cosine is an even function, we can rewrite the right-hand side again. So this will be cosine of theta is equal to cosine of 7 pi divided by 12. Therefore, this implies taking the inverse cosine of both sides, that theta will be equal to 7 pi divided by 12, which is equal to 105 degrees. Finding the angle between two vectors. In the exercise, find the angle theta between the vectors. U is 2, 3, 1, and V is negative 3, 2, 0. To find the angle theta, we can use the equation that cosine of theta is equal to vector u dotted with vector v divided by the magnitude of vector u times the magnitude of vector v. This will be equal to, carrying out the dot product, we have 2 times negative 3 plus 3 times 2 plus 1 times 0. And if we look at that, that's actually going to add up to be 0. So we won't even bother figuring out the magnitude of u or the magnitude of v, because it's just going to be equal to 0 anyway. Therefore, we know that cosine of theta is equal to 0, which implies that theta is equal to pi halves, which is equal to 90 degrees.
Determining a relationship between two vectors. Determine whether u and v are orthogonal, parallel, or neither. So u and v are vectors in R4, where u has components 4 and 3/2 and negative 1 and 1/2, and v has components negative 2 and negative 3/4 and 1/2 and negative 1/4. So we'll first try to determine if these vectors are orthogonal. So if they're orthogonal, then u dotted with v will have to be 0. So that's what we'll try to determine. So to find u dotted with v, of course, we'll just take the sum of the products of the corresponding components. So we'll take 4 times negative 2, and we'll add 3/2 times negative 3/4, and then we'll add negative 1 times 1/2, and then finally we'll add 1/2 times negative 1/4. And so this will give us negative 8 minus 9/8 minus 1/2 minus 1/8. And if we get a common denominator of 8, we'll end up with negative 64 over 8 minus 9 over 8 minus 4 over 8 minus 1 over 8. And so u dot v is going to be negative 78 over 8, which reduces to negative 39 over 4, which is not equal to 0, which tells us that u and v are not orthogonal. But are they parallel? Well, we can note that if we look at u, it seems that we could possibly multiply v by negative 2 to get u. So if we take negative 2 times v, we're going to get negative 2 times this vector with components negative 2, comma negative 3/4, comma 1/2, comma negative 1/4. And this will give us a vector with components 4, comma 3/2, comma negative 1, comma 1/2. And we can see that that's the same as u. So since u is a multiple of v, it's negative 2 times v, this tells us that u and v are going to be parallel. So u and v are not orthogonal, they're parallel. So they're not orthogonal because their dot product is not 0, but they are parallel because one vector is a constant multiple of the other.
Finding orthogonal vectors. In the exercise, determine all vectors v that are orthogonal to u. We have used the vector 4, negative 1, 0. If we want orthogonal vectors, then that means that u dotted with v should be equal to 0. We know that the vector u is 4, negative 1, and 0. And we want to dot this with the vector v, which we can just call v1, v2, and v3. And this should be equal to 0. Carrying out the dot product, we will have 4 times v1 minus v2 is equal to 0. So we have 3 unknowns, but only one equation. One of the values doesn't show up in this equation, therefore we're free to choose that value to be whatever we want. So we can just say that v3 is equal to some real number s. Next, since we have 2 more unknowns and 1 equation, we'll choose one of the values. So if we choose v1 to be equal to some number t that is in the set of real numbers, then we can set that v1 equal to t and solve for v2 to find out what v2 is. So doing that, we will get 4t minus v2 is equal to 0, which implies that v2 is equal to 4t. Therefore, we have that the vector v should be equal to t, 4t, and s, where s and t are elements of the real numbers.